Okay, this video tutorial looks at the mathematical strand of measurement and geometry, and more specifically, we're going to focus on angles in a triangle. Now, in order to understand angles in a triangle, we first need to have a bit of a grounding in being able to classify triangles. Now, triangles are basically a three-sided shape that can be classified by either their side lengths or by the internal angles they create. And as you can see on our diagrams here, we've got an equilateral triangle, which has all the same sides, an isosceles triangle, which has just two sides that are the same, and a scalene triangle where no sides are the same length. That's when we're classifying by side length. But if we choose to classify by angles, we're looking for triangles that have all acute angles, so that's all angles less than 90. We have what we call a right angle triangle, so if there's a triangle that has a right angle in it, or if we've got a triangle that has one angle that's obtuse, right, then we would call that an obtuse angled triangle. Now it's very important to understand that the sum of the angles in a triangle is 180 degrees. So if we look on the diagram we've got here, where we've got A, angle B, and angle C, when we add all those together, we end up with a total of 180. All right, we know we can prove this using our parallel line theory that we've been through already. In our parallel line theory, we know that alternate angles are the same, here A and A. We know that corresponding angles here and here are the same, all right? And we know that when you get C, A, and B here, it creates 180 degrees. So therefore, the internal angles of a triangle must also be 180 degrees. Just something to think about as well, that if we've got angles A and B here, and angles A and B over here, that this rule comes into play, where the external angle of a triangle is equal to the sum of the opposite internal angles. Okay, so you can see here on this diagram that we've got our angle here of x, and that's going to be the same as the angle A plus B. So we've got a couple of examples here where in our first example we're trying to find the missing value of x. Alright, so we know that if we add these all together, x plus 42 plus 74 is going to give us 180 degrees because the total internal angles of a triangle are 180 degrees. 42 plus 74 is 116. So x plus 116 is 180. Therefore, x must equal 64 degrees. In our second example, we've got y plus 80, and we've got 125 as our external angle. So remember, this is our second example. 125 is our external angle, and y and 80 are our opposite internal angles. So when we add them together, we get 125. So therefore, y must equal 125 take 80, which is going to be 45 degrees. Okay, so let's have a look at some example questions here. Again, very similar to the ones I just showed you. Find the missing angle in the following examples. Here we know that x plus 106 plus 33 must equal 180 degrees. Therefore, x plus 139 must be 180. Therefore, x is 180 take 39, which is 41 degrees. And here, the sum of the opposite internal angles, so A plus 51, must equal 112. Therefore, A must equal 112 take 51, which is going to give me 61 degrees. Okay, so here are some practice questions I'd like you to have a go at. Please feel free to pause the video. Once you think you've got the answers, continue the video and we'll see how you went. Okay, so let's see how you went. Now with our first question, it says identify the following triangle. we can see that it actually has two sides that are the same length, and two sides that are the same length is an isosceles triangle. So this triangle is an isosceles triangle. In our second example, we know that if we add all these angles, all the internal angles, we get 180. So we've got 2x plus x plus 72. That gives us 180 degrees. 2x plus x is 3x plus 72 equals 180 degrees. And now we're simply just solving an equation. I'll rewrite that x so it looks a little bit neater. 3x is therefore equal to 108, and x is going to be equal to 36 degrees.